Hey Anu, this is a video on Bayes theorem. First I thought I'll make one on conditional probability, a second one on total probability, and then we'll move on to Bayes. Now conditional probability is given by P of A given B. Now what does this mean? It says given that you have some information, and the information that you have is that event B has happened. So what is probability of A given that B has happened? It's given by P of A intersection B divided by P of B. Now the way to get some insight into this formula is, now given that B has happened, B becomes your new sample space. That is the universe of all possible outcomes. That's why it's in the denominator. Now given that B has already happened, now what is the probability of now A and B happening? That's why you have this ratio. To better understand this, let's take the concept of the Venn diagram. Say this green circle represents A and this blue circle slash egg thing represents B. Now the question, so this is the whole universe, right? This is the whole universe of events possible. So this is represented by a sample space S. Now I'm asking what is probability of A given B. Now since I have the concept of given B, I'm restricted to all outcomes that have to lie in B, right? Because B has already happened. So we know the set of possible outcomes lie within this circle. Now what is the probability that A has also happened? Now that region is gonna, so the region of interest is just gonna be this guy, right? It's this intersection part. So that's why you can see that the formula is going to be the ratio of this intersection region to the whole of B. So this is A intersection B. If you have any more questions on this, I'll explain it over a call D. Let's just do a quick example though. Say the question is, given that you toss a die once, what is the probability of you getting a 1 given that the outcome is odd? Okay, given that the outcome is odd, what is the probability of getting a 1? Now let's write down the sample space. The sample space when you throw a die is just going to be 1, 2, 3, 4, 5 and 6, right? And the probability of each of these is going to be 1 over 6. Now what is the probability that you get a 1 given that you get an odd number? So the given event B is just going to be, what is the probability of getting an odd number? That is 1, 3 or 5. And the event A is going to be, what is the probability of getting a 1? Given, so now I have restricted my sample space to B. So what is the probability of getting a 1 given that it's an odd number? It's a 1 or a 3 or a 5. We can easily see this is 1 by 3. Right, now let's apply the formula and get the same thing. Now probability of A given B is nothing but probability of A intersection B over P of B. Right, now what is A intersection B? The event 1. So that is just the P of 1 divided by what is P of B, that is what is the probability of getting an odd number. Just calculated this, that is 1 by 3. P of 1 is 1 over 6 by 1 over, I'm sorry, this is 1 over 2. Extremely sorry, 1 over 2. This is 1/3.